Good afternoon, sir.
Sir. Hello, sir. Sir, good afternoon, sir. Samitari, sir. Hello, sir. Hello. Samitari, sir. Sir. Hello, sir. Samitari, sir.
Is it audible?
Yes, sir. Now it is audible, sir.
Okay, fine.
Sir, good afternoon, sir. Namaskar, sir.
Good afternoon to all of you.
Sir. Good afternoon, sir. Myself, Dr. Ravi, sir.
Okay. Good afternoon to Dr. Ravi.
Sir, how are you, sir? How is your health? Everything is fine, sir?
Everything is fine.
Thank you, sir. Thank you so much, sir. Sir, even though you are having a hectic schedule, but you came forward and you are showing concern on our institute and our department. Once again, thank you so much, sir.
Okay.
Thank you, sir. Please.
It's a proud for me also. I am just sharing my knowledge. It's India basically sharing that all the knowledge so that everybody will be benefited from that research, and they will also continue their research.
Yes, sir.
Thank you for giving us the opportunity.
Sir, thank you, sir. Thank you so much, sir. Please, sir, you go ahead, sir. Madam?
Yes, sir. Yes, sir.
Madam, please you proceed.
Okay.
Will be joined.
Okay, sir.
Please you proceed, madam.
Welcome back all the participants for the day 2 session 3 on remote sensing ocean edge detection based on deep learning techniques. I also extend a warm welcome for this session keynote speaker, Dr. Pscmrcet, sir, Associate Professor, Aicte. Thank you, sir. Now it's my privilege to introduce this keynote speaker, Dr. Pscmrcet, sir. Dr. Pscmrcet received his PhD degree in Electronics and Electrical Communication Engineering from the Indian Institute of Technology, Kharagpur, India in 2009. He joined National Institute of Technology, Rourkela as a faculty member in 2009 where he presently holds the position of Associate Professor in the Department of Electronics and Communication Engineering. His research interests include signal processing, image processing, pattern recognition, and machine learning. He is the professor in charge of pattern recognition and machine intelligence laboratory and head of this laboratory research group. This group established 12 years back, and Dr. Ari has already supervised 6 PhD, more than 45 MTech, and 35 BTech final year theses. In addition, 7 PhD students, 4 MTech students, and 3 BTech final year students are presently pursuing their research work in the pattern recognition and machine intelligence laboratory under his direct supervision. Dr. Ari is a member of IEEE and IEEE Signal Processing Society, and at present, he is also serving as an associate editor of Aicte Image Processing Journal. He served as guest editor, Electronic Systems International Journal of Signal and Imaging Systems Engineering. He is a regular reviewer of reputed international journals like IEEE, Elsevier, Springer, etc. He has already published more than 65 research articles, including IEEE Transactions, Elsevier Journals, and his Google Scholar HMX is 17 with 1100 plus citations. He has also published 2 patents in the domain of machine intelligence, signal and image processing. He has successfully completed 5 R&D projects and doing another 2 sponsored projects in the area of machine learning, signal and image processing. He has successfully developed a data acquisition system for DRDO to test OTO MELERA naval gun. This data acquisition system is developed for acquiring the data from 16 analog channels, and software interface is developed for communication between data acquisition system and personal computer. The data acquisition system is interfaced to a computer for visualization of 16 channel data for graphical display. Hardware and software part is integrated to develop a complete data acquisition system which can store, analyze the signals individually. For DRDO, he has also developed a hand gesture based interface system for remote controlled surveillance mobile robot. Such a device is used for carrying out day-to-day security and surveillance purposes at sensitive locations such as defense establishments, strategic infrastructure, such as air traffic control towers and high-value chemical warehouses, determination of a person's daily activity and schedule, etc. He has successfully completed overall management responsibility to build a balloon sat of cylindrical structure, which is 20 centimeters diameter, 30 centimeters height, and 1 kg weight, test to common subsystems like payload, tracking, and telemetry control, and on-board system, etc. And it is used for the study of land area of Rourkela city over the state of Odisha. He was awarded as Young Faculty Research Fellow under the Visvesvaraya PhD scheme for Electronics and IT, MIT for the year of 2015-16, and got recognition from ICMR and National Innovation Foundation, India, for innovation and contribution in the field of science and technology in the year of 2015. He received SERB Startup Research Grant for Young Scientists in 2012. His developed system, the Heart Sound Analyzer, generated lots of interest among medical electronics industries and also in print and television media 2008. He received Best Paper Award in International Conference on Computer, Electrical and Communication in 2020. Now I request Samit Arisa to take over the session.
Thank you very much, madam, for your detailed things are described, but that much of this is a part of our every researcher. People are doing their work and they're getting that reward of these things. Okay, thank you very much, madam. Again, madam, is it visible? My screen is visible to all of you?
Yes, sir. The screen is shared, sir.
Yeah. Okay. Thank you very much. So today, our topic is remote sensing. Particularly, as you have seen that, just as you have heard there, our lab is engaged with artificial intelligence, machine learning, and all the techniques related to the application of signal and image processing. Broadly, we are working into the several applications, working on the several applications like of remote sensing, like of medical data, like of radio data, okay, and also the for surveillance applications. So remote sensing, one of our popular application domain, okay, where the artificial intelligence, machine learning techniques we are applying for the various applications. So we are, our group is involved in the domain of remote sensing, like of three popular domain. One is the one particular is the Himalayan regions, where the sudden floods are coming. Okay, so due to the glaciers, due to the glaciers melting, it's called of a GOLF, Glacier Lakes Outburst Floods. So our objective is to monitor these glacial lakes also to predict that glacier lake outburst floods. As you know that this is frequently due to the global warming frequently happening, these GOLFs in the northern India's, and for last 10 to 12 years. So it's a very, if you're able to predict by using the remote sensing techniques so that the downstream people will be safe. So another, so this is the one popular applications we are doing. Another applications we are doing the change detections. So due to the humans, I mean, activities increasing nearly the town, I mean, or city region. So lot of ponds and also a lot of water bodies are diminishes, or also the trees also, the cutting also. So all the things we can monitor by using the satellite imaging. If there is these types of progress happens, even for a forest fires. So if these types of progress happens, so that we can analyze it, that or we can protect it from that. So that type of remote sensing. Another popular remote sensing applications our group is doing is that ocean eddy detection based on deep learning techniques. So ocean eddy detection means, so it's a eddy when there will be a cyclonic eddy or anticyclonic eddy. From the remote sensing, our group also determining using the artificial intelligence technique. Today our topic is based on this only. Okay. So as you know that the people for going to the ocean where these types of eddies happens is very difficult, very time consuming, very risky. So it is better to always to predict these types of cyclone using the remote sensing. For that, using the remote sensing applications. So here, today's topics, therefore, we will discuss on these remote sensing applications. One of the remote sensing applications, which is the ocean detections. So in this particular topic, in this today's lecture, we'll cover that how these eddies are created. Okay, how these types of eddies in ocean eddies are created. what are the different parameters related to this ocean bodies. For example, the surface temperatures, ocean optics, sea surface heights and currents, winds and wind stress. Okay. So also we'll discuss about the Coriolis effect, Ekman transport, and few reported works, earlier reported works, and what are the research possibilities are there in the domain of ocean eddy detections, which is very popular nowadays. So that all the things we can discuss in this particular session. Okay. Now the first question is that it is the complete session is the complete STC is the remote sensing. So it had some remote sensing has had some lot of advantages, you know, so it's not required to describe again. So its main advantage is no physical contact, and is that the people are not required to go in the particular region where the analysis is required. And so based on the satellite data, the satellite data are to be collected and it should be interpreted, and then you can get your required information from the data itself. Okay. So therefore, a lot of satellites, last 100 years, more than 100 years, that lot of satellites are sent for these applications, for the remote sensing applications. So first invention it is come for the remote sensing is important. That is coming that the 1839, where the remote sensings are, after that the remote sensing is from the photography itself, after that the remote sensing, the field that remote sensing is possible. And later on 1860s, the balloonist who is who is fly the balloons, these balloonists, they captured some pictures from the Earth's surface and analyze it. Yes, it can be, if I'll do the far distance or far height from the species from the ground Earth surface to RI, so you can get a lot of information which can detect, which can able to give you the information about the Earth surface. So in the early years, when the pigeon flits, so another form of remote sensing is also. So these are the very initial steps for the remote sensings. So if I'll go for our ocean applications, so ocean applications, the remote sensing in because as you know that the most of the parts of Earth is the ocean or the water regions. So oceans are sparsely occupied and also the vast. So where the cyclone gave part, or where the cyclone started, from which point, it is very difficult to go for a human, for a person by person and judge it that this particular position the cyclone started. So this cyclone, even if it will possible to judge, but you cannot predict it, that where which will be the directions of the cyclone without the automatic methods. So therefore the ship-based measurement is expensive, time consuming, it's very difficult to get where the it's a started. So in this way, the satellites can give you quickly these types of data for large areas of the images. Okay. So therefore, the satellite images are very important for these types of applications. Now, question is that what are the different satellites are there? Which satellites will be useful for it? So there are different types of satellites. We can notice. We can notice it. So the geostationary satellite. Okay. So low Earth orbiting satellite. So all the satellites are there. So it's a Landsat satellites. We'll see that what are the features. Mostly popular satellites used is the geostationary satellite. It is approximately, the altitude is 36,000 kilometers. Okay. The velocity is also that is 3075 meters per second. And in the 24 hours, one time it will do, it will rotate along the Earth axis and it will move from the west to east. So it has a lot of applications, the meteorological applications, communication applications, etc. Examples of the INSATs, a lot of Indian ISRO also sent a lot of geostationary satellite, for example, INSATs. Another satellites will discuss about the sun synchronous satellite, which is the lower in altitudes. You see that geostationary satellites is the higher in altitude, but here in the 817 kilometers. So obviously that the resolutions will be high as it is very close to the Earth's surface. So it's an Indian remote sensing series are the Indian remote sensing IRS series are these types of generate national resources information in varieties of application areas such as agriculture, forestry, geology, and the Earth observations also for these types of science. You'll see that the popular satellites people are also used that for remote sensing, which is the Landsat satellites. It is a popular USGS. Okay, in US satellite, USGS, website satellites, a lot of data is indicated from the Landsat satellites. So it is above of 1714 kilometers above the Earth's surface. Every 16 days, satellites will return the same spot. That means in a particular place, the satellite will take a picture every 16 days. It has the 30 meter of resolutions. So track it main objective, its a main use is that, so it's a to track the land use and land change. That means the change detection, we say these types of satellite popular used. A lot of satellites are there. The three-part satellite, one satellite, number of satellites. We are mainly using that Landsat satellites or specific satellites for these types of remote satellites. Now we can see there are two different types of sensors for satellites. That means, so satellite is using some sensors. One is called the passive sensors, another is called the active sensors. So passive sensor are that type of microwave instrument type of sensors that will receive the data, and from the received data they can measure the natural emissions, which can generate the signals, or we can transmit the signals for measuring a specific applications by the sensors that are refracted or scattered by the Earth's surface. and it will be received by the sensors, and these received data can be analyzed. These received data can be analyzed, and also that we get we can predict the specific things. Now we can see that the ocean remote sensing satellite. So Pscmrcet was the first Earth orbiting satellite designed for the remote sensing of the Earth surface. So we first use the right side, you can see that the Google images of the Pscmrcet, which is first sent for the ocean remote sensing. These objectives of the these types of remote sensing satellites is to collect the data from the sea surface, for example, of the winds, temperatures, surface temperatures, wave heights, atmospheric water, sea ice, etc. And it can that collections it can send for the to the ground for the analysis. So what are the instruments is used in the satellite for this one applications? One is the main popular application, the main popular instrument used for this applications is a altimeter. So altimeter is generally measures the altitudes from the satellite from the ground surface of the sea surface. So it is also that microbe scatter meter, scanning of multi-channel microbe radiometers, visible and infrared radiometer to identify cloud, land, and wave pictures. That's also are used in these types of satellites. Now, when you talked about that satellite, now we are entering that for the ocean eddy detections, what are the things are, what are the parameters? One important parameter is called the sea surface temperatures. So the most of the standard measurements from the satellites are the passive measurements. So here most recently use the microwave device that have also a lot of problems, like it can see through the clouds, but the signals is weak. Microwave also provides the other data such as wind speed, water vapor, rain, ice, etc. So if you look here, that when the IR or a microwave emissions as they are, the signal is received from the sensors, and sensors will send to the ground station for the raw data, and correspondingly from the microwave emission, that data will come to the data here in the ground earth stations, and these signals it will be processed. Okay. So from that signals we can get the what is the sea surface temperatures, what is the wind speed, all the parameters. We can, what are the water vapors, all the parameters we can determine by using these types of sensors. So why the sea surface of temperatures SST is very much important? Because it's related to the global warming. When the temperature or a global temperatures will increase, the ice will be melted and the sea level also increase. So to monitor this, so SST or sea surface temperature is also important. is also important. It's also the it also indicates the characteristics of the ocean currents and also upwelling and downwelling. Okay. Now another important thing is the ocean color remote sensing. That means what is the water colors are there. We can also see that from the passive measurement. Measures light scattered or transmitted upward through the ocean surface. Most of the signals, more than 90%, the satellite is not representing the ocean. Because it's a main problem is that the sunlight has been scattered and reflected by molecules and aerosols in the atmosphere back into the satellite's field of view. So therefore, the ocean color, okay, so ocean color, it is very difficult to original the water colors, is difficult to reproduce. So you can find here from the sunlight, which is absorbed and scattered from the visible light, depends on the pigments of the water or the water colors of the waters, and also it will be sensors. And if you go for the if you receive by the sensors, and the sensors will that information send back, and if you calibrate it properly, then we can determine the what exactly the color is. Okay. So therefore, directly if you will use the sensors analysis, the data is very difficult to get the what actually the ocean. So one important parameters, other important parameters is called the sea surface height. So it's a active measurements for height of the sea surface, SST, SSH, sea surface temperature SST and sea surface height SSH. These are the most important parameters also. So it generally is the active measurement in satellite. It have look that satellite is having some sensors. It will transmit the informations and it will be reflected back from the sea level, from the surface of the seas, and it will receive from the satellite sensors and it will be diffused. So here, so pulses or the informations or which will be sent to the Earth surface, the sea surface, and when it will return, then we'll process it, and it will send to the ground station, and we'll process it. Then we can calculate the ocean currents and eddies. Okay, eddy means it is a which is a possible which is responsible for the possible creations of the cyclone. Okay, so we'll first determine there is a creation of the eddies or not. If it is the eddies are there, then this eddy is cyclonic eddy or anticyclonic. So cyclonic eddy creates the cyclone. Anticyclonic eddy, after that it can change to the cyclonic eddy, but little bit also if those who are not, it can be little diminishes. So here, what we can measure from these types of microwave radar or using the active measurements, we can measure the ocean currents or eddies, and we can measure the sea surface deviation, surface depth. So we also see that we can also determine the sea level rise due to the global warming. We can also determine there are the variability, physical or internal variabilities like salinities, etc. So these types of from the sea surface, from the active measurements. So in this particular block diagrams, we will try to show in the diagram that here the satellites are there. People assuming it's a active satellites. So when active sensors, when it will transmit the information to the sea surface, and it will be reflected back to the satellites. And if these satellites data sent to the ground station, that it can be analyzed and it can detect what will be the wind speed, what will be the roughness of the sea surface, and all the emissions can be measured. So here, look that as you are using the radar, not the imaging part. So that's the cloud will not affect these types of analysis. We are using a radar signal, that's why. So in this way, you can measure the wind spread, wind stress or wind speed based on the roughness of the sea surface. So as an example here, it is shown from the Pscmrcet, is one satellites, high resolution, extensive and frequent wind velocity measurements is used to understand the ocean circulations. So therefore, the wind stress and wind variabilities so it can be measured. So look that here the wind stress in turn, I can say that it also creates the large scale surface current of surface means sea level surface currents. And for wind speed variabilities, creates the large scale ocean circulations. So ocean circulations, whenever there will be ocean circulations, that creates the eddies also. We'll come there. Now we see that two different sensors are used. One is the altimeter, another is the scatterometer. Okay, if the first figure represents that altimeters, so here that altimeters, the data and scatterometer data, if it represents the tropical cyclone heat potential from the altimeter data, the tropical cyclone from the Katrina and Rita, it is shown here. So in the left and right, that two different cyclones, their heat potential is represented using the altimeter and scatterometer. So here the hurricanes creates here, the paths of hurricanes creates indicates the circle, indicating by this circle and its colors, representing the intensity of the storm on the Gulf of the Mexico. So this is shown in the Gulf of the Mexico using the altimeter. So here that we can see the sea level rise using the altimeter data from this figure. This is a two-dimensional data. So from the altimeter data, we can estimate the global sea level rise. So that there the rise is two defects. One is the thermal expansions as the water hits. Another is the increased volume of water as the glacial ice melts. So for these two reasons, there the sea level can rise. That can be noticed from the altimeter data. So next few, so we have what we have noticed here. We have seen the different sensors what are used for the sea level rise and also the eddy current detections. Now we can see in the next few minutes we will discuss about the generation, about the how the eddies will be generated. So it's two popular effects we'll discuss. One is the called is Coriolis effect. I'll come that Coriolis effect more detail. Let's see that what is Coriolis. So if you see that stationary platform in your Earth's surface, okay. So when the people are sitting on a small place which is rotating, okay, say suppose of one place when the two boys are these parts are rotating, okay, these are the sitting here and here, okay, and they are throwing their balls. This person is throwing the balls and this person receiving. But when the circular body is fixed, then this person easily or fixed or stationary. So these persons are easily receive the balls. So therefore it's a receiving. But when this will circulate or these platforms will rotate, if you look that again, when it is the speed is more, this person is throwing the ball to second person, and look that this person is unable to receive the ball because as these platforms also rotating, okay. So this effect is called as a Coriolis effect. Now we can find the Earth also. Look, that Coriolis effect will come in that is noticed on the Earth's surface. So here the northern hemisphere part of the Earth, it is rotating, and southern from that side, from the west to east. Okay, if we look that, it's the east to west, whereas southern hemisphere part is west to east, from left to the right. Okay, so that creates the Coriolis effects. I'll come in more detail how Coriolis effect comes to the point. So we can find the effect is called the Ekman transport. Okay. So what is Ekman transport? This Ekman transport and Coriolis effect is the responsible for creation of the eddies. Now, what is this? What is the Ekman transport? You can find that on the sea surface. This is sea surface. and this is the air. The wind is flowing through the sea surface, and this is the water. Now, when the sea surface, the wind is flowing, there is a friction between the water and the wind. Okay, that frictions will be available on the sea surface. Due to this friction, that generates a surface current. Look that this surface current creates a surface energy. Okay, so this surface current will dip to the 50 to 100 meter also towards the water. And due to this friction, the surface current, it will not go through the surface of the water level. It will be angled on the 20 to 40 degree angles of the through this surface current will flow to the towards the water, deeper into the water with the angle of 20 to 40 degree angles. Now look that from here, the question is that how this surface current, due to the surface current, what is the effect of, question is that what is the effect of this surface current? Later on, scientist Eggman has proposed a analysis by which it can analyze this, the effect of surface current. He thought all the water in terms of the levels. That means he's created a level. Okay, so create a level throughout. He thought about a level throughout the deep of water. This is the level. Okay, so created a level of the deep of water, all the levels. Now, so therefore, when the surface energy, when the surface current, or in terms of the energy will pass, it will be shifted like of this way. This is one layer. This is creates another. This creates of another layer. So this is creating another layer. So due to the, so assuming that first, this is the layer. When there will be a friction due to the surface current, this layer will move one by one. First layer will come like this. Second layer, it looks like this. Third layer, it looks like this. So that layer wise, the layers will come off like a sliding of the layers. When this was, the layers will be slided. So the layers means the water levels are slided. Layers, what are the layers means? The layer of water. Waters are slided due to the surface current or surface energies. When there will be a layer of basically layers are slided like of this one, this generated the rotation of layers. When there will be a rotation of layers, that means the rotation of the water. So that means, look that this wind speed, according to the depth, So that wind speed and the energy or a surface current generation, it's a almost 90 degree out of phase. So start from 20 to 45 degree, and then it is a rotating off towards of these directions. And these rotations is due to the Coriolis effect. These rotations are coming due to the Coriolis effect. So as you know, the Coriolis effect, the upper part or a northern hemisphere is opposite to the southern hemisphere. Not that the Coriolis affects that the directions will be northern hemisphere opposite to the southern hemisphere. So therefore, due to the Ekman, due to the transfer of energy, Ekman using the Ekman transport is also the opposite towards the northern hemisphere and southern hemisphere. Okay. So therefore, you can see that the wind speed and the Ekman transport energy, it's a perpendicular approximately. That generates the upwelling and downwelling of the water. Upwelling and downwelling of the water. So therefore, we can see that when it comes to the seashore, this is the part of the seashore part. Okay, and this is the wind speed towards this direction. This is the seashore part. Towards this direction, winds are coming. So therefore, according to the Ekman transport, mostly the energies or the water will go for this direction based on the Ekman energy transport, this direction to this. And populations of the water. So when in the seashore, when the wind speed is coming from the north to south, so the water will move from the west to east, and there will be upwind circulations of the water. And similarly, this is the upwind circulations of the water. Similarly, for when the wind speed coming from the south to north, then the Ekman transport or water will move from the west to east. Okay, so then there will be a downwelling, because when it is coming to the Ekman transport, so to fill up this region, so there will be a water will be in the downwelling. So in this way, we can find there will be a water movement towards the seashore. So is it possible only water movement of seashore? No. Is it also? It is also possible in the sea surface also. Okay. If you look here, the sea surface. Okay. So this sea surface in the near to the region. So here will be, if there is a winds are from the east to west. Okay, here winds are comes from the east to west, and there will be upwelling of water. Okay, and also there will be a downwelling of water to fill up the thing. So not only the sea surface, this upwelling and downwelling is there, but also the oceans, there every time this upwelling due to the winds, there will be upwelling and downwelling of water. That creates a huge of water movement to the ocean space. And you can find there will be huge of water circulations of the ocean. When there will be water circulation, there will be a water circulations. that creates that generates the AD that form the AD. Okay, so that form the ADs, and these ADs are two types of ADs. We find one is the cyclonic AD, another is the anticyclonic. Cyclonic AD is more dangerous, so we need to determine that where the first we have to using the machine learning technique, we need to determine where the ADs are created, and these ADs, what are created, these ADs are cyclonic AD or anticyclonic. Okay, and also our objective is to track the path if there is a ADs are detected. Okay. Now, as I have told that we have discussed what are the satellites are available, what are the difference of sensors we are used for the ocean, particularly we use the altimeter data. So what are the sensors are there for the ocean AD current detections. Okay, so and also we have discussed how the ADs are generated. Okay, so broadly, and also we have seen that a lot of advantages, disadvantages of sensors, etc. Okay, so due to the using the Ekman transport and also the Coriolis effect, how the ADs are generated. Now, our objective, I have defined the objectives are to determine to detect that where is AD, and after detection we need to determine or need to track the ADs. So we'll see that traditional algorithms are based on the empirical physical parameters, threshold values, and also the threshold values that are sensitive to the many factors, such as the distributions of chlorophylls. Okay, that means chlorophylls means the green regions on the sea surface, deformations of the velocity fields, spatial variability, all that will depend. So based on these empirical physical parameters, we want to replace the AI-based techniques. Now the AI-based techniques also popularly used for the AD detections. Okay. Particularly the artificial intelligence, okay, which is employed the powerful machine learning techniques, okay, though is used for these types of AD detections. Now, we'll also discuss that in the brief, that what is machine learning, deep learning, and artificial intelligence, all the things we'll discuss in very brief there. So here so existing the deep learning techniques, what are the different available deep learning techniques? It's a generally neglect that the captures of the edge detections part, but the accurate edge detection is very difficult. General available deep learning techniques. So we'll see that what are the different types of, based on the deep learning technique itself, what are the different models can be created for these types of AD detections. Now these are the very challenges because of only the convolutional neural network or deep learning techniques available that are not directly applied for the AD detections. So we'll see in more detail of that. Now, what are the literatures available? We can divide the whole literature in 4 different categories. One is the geometric meshed methods that are very simple but cannot detect the AD details from the data without clear geometrical features. So geometric methods are available. Physical parameters based methods are also there. Most of the techniques available, techniques of the physical parameters methods, they need some threshold techniques, etc. They need a set of suitable threshold for specific region of interest. Okay, these techniques are task specific. Specific applications are generally used. So it's not a generalized one. That means for a specific place, it can be used. Okay, so available techniques are mostly the physical parameters based techniques. Now also, there are a lot of techniques available for handcrafted features based methods. So it's a particularly the low level features based on the experts' prior experience and knowledge. We generally represent the ocean eddies. So that means according to the the experts tell that, okay, expert says that, okay, if you use the surface temperature and if you use the wind speed, it can be measured. So use the two features and applied to the machine learning techniques or back propagation algorithm, you will find the performance. That's poor performance. So therefore, the objective nowadays people are doing. So both are physical based and handcrafted based. Both we are taking advantages, and also the experts' knowledge they are taking, and then they creates a noise-free history data to properly execute the detections. Okay, so we have taken of references of these types of references as you referred papers. So here we shall discuss few methodologies for ocean eddy detections. One is sea surface height based approach for ocean eddy detections. Okay, actually it's a nothing but a software that can identify and automate track the ocean eddies. Okay, if you look at the earlier methods, we look on these types of methods. These types of methods mostly use the handcrafted and hybrid methods. What you are going to say for the determinations of the eddies. So what will develop here? Objective is to develop a software model. It may be based on the machine learning model or deep learning model, or the advance of deep learning model to determine. So this type of software requires the sequential maps of sea level anomalies provided by AVISCO data, which is the archive, validation, and interpretation of satellite oceanography, and now distributed by the CMOS, the Copernicus Marine Earth Environment Services. So therefore, we need the maps of sea level anomalies. Okay, so sea level anomalies maps are required, essential, and that is that we are getting from the ultimate data. So these, what is the outputs of these types of data? This contains the eddy properties, positions, radius, amplitude, geostrophic speed, and also this type of output data shows the sequential height maps with active eddy centrals and tracks. So we can find out the right side image, which is referred in this reference papers, in these journal papers. It is a filtered image with the sea level anomaly, which is coming from the altimeter data set. This filtered data particularly is a cutoff values. The hypers filters is used with the cutoff frequencies is the horizontal velocity and vertical velocities at 10 km and 5 km respectively. Okay. And from these sea level anomalies, we need to determine the where the eddies are there. To determine the eddies, we need to calculate the contours. So look that here the lot of contours are calculated. Okay, lot of contours are calculated, and few contours are tracked also. This is the path of tracking. Look. Okay. So that to identify the cyclones, then first we need to, the contours are searched from 100 meters downward. So what we'll do, we'll search from the original SLA map, we'll search from the minus 100 centimeter to plus 100 centimeter and 1 centimeter intervals. And why will search? For searching towards the closed contours. Look, this is the contour determinations, nothing but an image processing techniques. Okay. So that we first objective is to find out the closed contour determinations. So that means from that closed contour, we have to determine it is a potential eddy. Okay. Now, a closed contour, when we determine as a contour, there are 4 different characteristics. If the shape with the error is less than 55, if it is the content pixel of I mean to I max in between of that I, where the I mean is set 8 and I max is 1000, and there are no more than one local SLA maximum for an anticyclone, and have an amplitude is the 150 centimeter within this. Then this will be a closed contour. Now look at how to determine these types of effective contours. The closed contours are not all the contours are effective. We need to determine the center of the effective contour. Okay. Now, when the closed contours, okay, how the contours are done, we need to search that from 1 centimeter, from minus 100 centimeter to plus 100 centimeter for each and every pixel, and find that what is the closed contour. If it is the follows these types of all the rules, then we find the closed contour. And if it is the contours are there, then it is identified as an eddy, and it is referred to as C effective. It is referred to as C effective rate. Okay. Now another look that the eddy is called the C effective. It is represented in that paper itself, that C effective, that this is the closed contour. Okay. Now, there is a L effective also determined. That means is the centroid of this contour is defined as a L effective. Now we need to find out a contour which creates a minimum areas from the center itself. So here we can find out that should be a minimum between the 8 mean to 8 to 1000. So that in that region, when you search towards the contour, which is the close towards that pixel by pixel, we can find out this is the black part is the more effective contour where the center is given is a L space. We determine is a speed based contour. It is the L space that is the effective contour. Now that this is the diagram where the shape error will not take off these types of contour, and we will take only the when the error is less than 55. When the error is less than 55, that contour I will take only. So therefore, these all contours are not effective contours. The effective contours are determined based on the determinations of the error. So in this way, we can determine as it is given that which one the effective contours. Here all the contours are there. So when all the contours are determined, these contours are nothing but a AD. So these ADs, okay, these ADs from the sea level anomaly map, what we got the ADs, these ADs need to track. So for tracking, look here, we'll have a position of P track. We are having a position assuming that a P track, this is the position of a contour, which is the AD. We are having a P track position. And then track the position when if it is a dropped. So we go for a from that P track to that effective track continuously. If there is a drop of that track, then we'll find that according to the track when we go for, so we'll track the ADs. So we'll always searching of these types of contours from where to where, from the steps K to K+1, we'll searching for these types of computing. So in this way, the track according to the when the contours will move, the tracking also move from the each stepwise. So that is given in this figures. And this is the tracking path it is given. So that every contours are tracked here, and the ADs, the detected edges are tracking from one portion to the other portion, one position to the another portion. That means so from one ocean, one region to another. So these all the methods are generally used for data classification or ocean eddy detections, generally used for it as a ground truth. Okay. Now we'll apply the convolutional neural networks for eddy detections. So I have shown here very briefly the convolutional neural network. Okay. So you can find the earlier speech and etc. for convolutional neural networks in more detail. Here only dog and cat determination you can find. There is from the image, or you can say that SLM map, there will be a convolutional layer, max pooling layer, and convolutional layer and max pooling layer. So max pooling layers are used for the reductions of the data, and then the flattening will be done, and then the fully connected neural networks will be used for classifying the dog and cat. So in the convolution layers, what happens, etc., that you have, you can see that in other lectures also, what are the different things in details of that one. So this is the structures of the convolution neural networks. And this is a LeNet 5 architectures. It is shown. This is a LeNet 5 means is the 5-layer architecture. It is shown here. Okay. So it's a, for any image classification and character recognition, we have applied it. This is a basic architectures of the convolutional layer, subsampling layer, that means it's a pooling layer, and followed by again convolutional layer, subsampling layer, and then fully connected neural networks. So after the flattening, we use the fully connected neural networks. So this is the LeNet 5 architectures, and we generally the popular use of deep learning techniques is a transfer learning. So these are the models are there. We can find out that AlexNet, VGGNet, SqueezeNet, GoogleNet, all the network layers are given. And these types of layers are used for the to knowledge transfers. So here the knowledge will be transferred to these types of popular architectures to your model, so that this the model, your model will be trained properly, and the unknown data will come tested. It will be tested properly. Okay, so this is called a transfer learning based approach. Now you'll find there it is the information. This is the very popular algorithm for the classification for deep learning transfer. Now towards it, I have shown the very popular algorithm, and sequentially I entered what will be the problems of these types of popular algorithm. I'll go for more detail towards it for the implications. Now, people use the CNN or transfer learning techniques, though these are the very popular technique for the image classification or the segmentation, but still they are unable to determine the exact boundary of the eddies. Okay. So therefore, we'll apply the for more popular algorithm, UNet, more popular architectures of deep learning architecture. It's called UNet architecture. It shapes like a U, looks that it's like a U. So it's called of a UNet architectures. Okay, this is more applied for the segmentations. It has two parts, basic parts. One is the called of an, this left side part is called of an, okay, it's a encoding part, and right side part is a decoding part. Okay, the left side is a encoder and right side is a decoder. So encoding, which is downsampling, that means it's nothing but a informations are more compact. Okay, and right side is the decoding, which the informations are deconvolutions. So here in the convolutional layers we have seen in that deep learning architectures, here we have shown that convolutional layer and followed by the max pooling layer. Okay, here also we are using that same concept of deep learning technique. Here we have used the convolutional layer followed by the pooling layer. And we have used the ReLU application, rectified linear unit activation functions, and batch normalizations of the 2 by 2 max pooling layer. Okay. So in this way, we have 3 steps. After taking of 3 steps, we got encoded values. So that the information for the segmentations, we use the deconvolutions. Okay, so that encoded part means this information SSH image, sea surface height image, SSH image, sea surface height image is encoded here. We use the max pooling layer also, and stride up 2 here. So these are concatenated. Now, when we use the deconvolutions or transposed of convolutions, and we will get off a high level data to segment. Then the ADNet, from the ADNet, instead of these all the physical parameters what we have seen earlier, we use the image processing techniques note here for the image classification, particularly using the ADNet. Okay, we can able to directly segment it, which is AD or not. Okay, segment it where the exact there is a cyclonic AD or anticyclonic. ADs or not, I can directly get from the SLA map, and from here I can classify, segment it, the cyclonic AD from the anticyclonic. So these are the referred paper is also given from where the concepts are taken. But later on, researcher found very recently, we find that this is a 2021 transaction status. So very recently, researchers found, yes, units giving the performance, but we need some more better segmentations, which is machine understandable language. Okay, so it's called again semantic segmentations. So look that the concept of semantic segmentations refers to the information which is some sense of meaningful for systems. So semantic segmentations are when I use the, so some segmentation here is the dilated convolutions. When the dilation is 1, where 1 by 1 convolutions. When dilation convolution 2, when it is more segregated. Dilation convolutions 3, it will be more, what we can say that more spreaded or more flattened objects. Dilations of 3. Obviously, the performance as you have seen the encoder and decoder, its performance better. They have used the encoder and decoder model, so it is adopted for the semantic functions. So that we can find the 4 different categories. So this one category can be mixed with the other categories. One, the dilated convolution, encoder and decoder, context embedding, and attention mechanism. What is context embedding? Introducing here the semantic segmentation, that is semantic information is introduced here in the low level features. And also that high level features also would generate. This generates of low level information, semantic informations, and high level informations in the embedding more special information in the high level features. So not only the encoder decoder, but also they have done for the embeds. And also that another techniques of attention. So deep convolution neural network, attention can be in the deep convolution neural network. attentions can be considered as an important mechanism when you select the features. So these features will be more distinct and informative. Now we'll discuss of more detail about this recent papers. Okay, so they have taken up the SSH image, sea surface height image, and they have used a deep framework, and this is for automatic detections and tracking as reported in the reference of 3. So here they have detected that boundary can be extracted from the eddies, and they have also tracked the eddies. So during the tracking the eddies, a lot of persons can ask that, why you are not using the LSTM? Yes, it can be used. The long short-term memory is capable to fuse the past information. It's the memory, as it is known, past information, and it's also, it can be used, but due to its computational cost and cannot distinguish different types of eddies, is rarely used of these types of instruments. So we can find in that paper, this is the architectures that they have used. Look that these architectures use encoder decoder model along with embedding of informations. So they have done this. They have done that encoder decoder. They have done along with context embedding. They have done. So that these two features, the two informations they have added, that encoder and decoder model, as you have seen the unit model for segmentation, or that means for classification of segmentations of the cyclonic or anticyclonic eddies. So they have used in the encoder model exception model, but instead of a normal exception model, they have modified this exception models. So that creates the low level features. This exception model creates the high level features. Okay. So here the informations are simply concatenated. So these are the deep learning model. This is a deep learning framework by which they have segmented the eddies. Okay. So they have used a 1x1 convolution, 3x3 convolution, 3x3 convolution, and this is using the Atlas rate. I'll come that more. What is that one? This Atlas rate of this one, 16, 12, and 18. And after that, they have concatenated and used for the upsampled it and concatenated again, and in the decoder model, they classify the model. So this is the model they have used for the segmentations. Now we can find that in the encoder model, that feature maps and the reduces the encoder model gradually reduces the feature maps and captures the higher semantic information. So here they have adopted the stride of 18 to 16. This is nothing but a stride rate. 6 to 18 they have used for the stride. Stride means, as you know, that convolutional neural network is already, you can see that from our earlier lectures. The convolutional neural networks, what we have used from here, the Stripes is nothing but a reducing, is used to reduce the data. So these are the deep frameworks are used by them. So here the convolutional exceptions model, here the normal exceptions model, standard exception model is used. Okay, so entry level, model, mid level, and they have modified is that one using the different additions of the depth-wise convolution, point-wise convolution, and asterisk convolutions. They have modified of these types of things. Where the depth-wise convolutions they have added with the point-wise convolutions, and this is the asterisk convolutions added. So this is the modification is made in these transactions. So the proposed depth-wise convolutions and point-wise convolution. This is the pixel-wise convolution, and this is the depth-wise convolutions. And also, this is the modified depth-wise convolution. More in the depth-wise convolution is more, the informations are more dilated. In this figure, they represent the three different type of convolutions. As you've seen that here the image from that convolutions, then pyramid, this is the pyramidal convolutions, it is top, it is given, that image then convoluted, that image size is reduces after the convolutions. Then they have used the pooling, and then it is appended, and after that they have used the decoder. So then this is the predictions or the classifications. This is the another, they have used the point-wise convolutions. You can find out. This is the encoder part, and decoder is the point-wise convolutions. This is the encoder decoder with the arterious convolutions. Okay. So in between it is a hybrid of these two different convolutions. You can find that it can be predicted. Okay. So all the different convolutions they have used here in the different convolutions. They only modified the exception models that is given in the field. And this model is proposed for the segmentations, and deep model performs better compared to the they have shown in the deep framework. Okay, they have shown that original exception architectures to modified exception architectures, maximum in operations with the depth-wise separable, depth-wise separable. This is the depth-wise separable convolutions they have used. Okay, and they have also for batch moderation, ReLU and 3x3 depth-wise convolutions is used. Now the question is that for any classification or segmentation algorithm, people are using confusion matrix. So confusion matrix, it will generate, it will, as you know that if you are having 3 classes, or you can say right 4 classes, whatever there, assume it is 3 classes. The classes are A, B, C. Here also A, B, C. Okay, so it is 4 classes make it. So as you have done the 4 classes here, so it should be confusion matrix A, B, C. Now, if it is A out of assuming that you have taken of 10 different test data, it can be if it all A is this or all A are classified as A, so it is A is 10 of 10. B also another 10 data was there. So assume it is a 9 data, another B is collected as a C. B is tested as a C. So here, this is all 0 values. And assume you see, it is a 7 data is collected, 1 is detected as a B, another is detected as a D. Whereas D is detected as a 5. So the 2 will be A, 1, 2 is a C. So in this way, this is called a confusion matrix. So we can find out The true positive for A is 10, whereas true positive for B is equal to 9. Whereas true positive for C is equal to 7, for true positive, and for D is equal to 5. So this is called as a confusion matrix. So this confusion matrix is not confusing. Look that. The predicted values is matched with the actual values. So that means out of 10, if it is a 10, then it is called as a true positive. Look here. When the cat is, there is two classes here, cat and dog. When cat is detected as a cat, then it is a true positive. So here all A's are detected as A, so it is all are true positive. When cat is detected, not detected, when cats are not detected, then it is called a false negative. This is type 2 error. It is called the false negative. Okay, as you have seen here, that false negative. B is detected as a C, so it is a false negative. C is detected as a B, false negative. When false positive, look that though it is the D data, but detected as a C. So for the C case, this data is false positive. So here the cat, though it is a dog, but detected as a cat, so it is a false positive. When for the cases of cat, when dog is detected as a dog, so it is called a true negative. So this is what we have discussed, that 4 different metric. One is true positive, TP. Another is called false negative, FN. Another is called false positive, FP. Another is called true negative, TN. So that we are interested of these 4 different metrics by which we can generate. Okay, so this is false positive, false negative. So by which can generate the different parameters or sensitivity, positive predictivity, precision, recall, F1 score, all the things can be generated. So it is given on the precision and recall. It tells us how many correctly predicted actual timeout of the positive, and recall, precision, true positive divided by true negative plus of true positive. Recall can be also generated. So these types of metrics can be easily generated from the confusion matrix. Okay, so it is very, very popularly used in the artificial intelligence technique for better work or pattern classifications of these types of metrics. Okay, so F1 score, as I have told, is a harmonic mean. Okay, for precision and recall, it gives a combined idea about these 2 metrics. It's also maximum when the precision is equal to the recall. Okay. Now for the AD detections, what we are coming from the earlier, that these papers, now I'm coming that after that from the deep framework, this paper from deep framework for AD detection and tracking using satellite sea surface of Aicte data. From this is the result for the detections. So they have detected, this is the cyclonic eddy, blue one, and anticyclonic eddy for that's 12 months of data, and they tracked it for the 12 months. You can find out the cyclonic and anticyclonic, and it is tracked positively in the continuous terms of latitude and longitude wise. It is given and it is tracked. Now they have also in these papers, they have given is a loss and train and test data. Okay, and they are showing the performance there. You'll find this is the AD net. This is original SSH image. SSH means sea surface height image. By using the ADNet, the segmentations is poor. This is the original ground truth. But using the edit tracking algorithms, it is better performance can source. You can find out that the performance are better for the cases of using their methods. Now, what are the shortcomings? Semantic segmentations, which is a dense pixel-wise classification task, faces two main challenges. Most backbone of segmentation model that often were extracted from pre-trained classification model generates a poor performance. Okay, and the gap of combination between the high level and low level features in segmentations model, only if you directly merge it, it's also it's inaccurate performance. So therefore, we should have the semantic segmentation with a, as you have told, with a backbone model, as you have told here. This is a requirement of attention mechanism. We need to weight up. We need to give more weightage for which performing better. So there are more attention to be given that type of network where the performance are better. So later on, found a paper which is not in this file, but street scene applications for segmentations. Okay, so for that street scene applications, we can find out they have given a weightage where the performance is better. You can find out it captures the rich, spatial, and abundant semantic information simultaneously. It is called the tailored backbone structures. So what they have done? They have incorporated the attention mechanism. The two attention mechanism incorporated. One is called the channel attention select module and spatial attention select module. It's called CASM and SASM. It is reported in their interchannel or interspatial relationship of the features. So that low-level features and high-level features, their channel attention mechanism, they have added it and got the output by using the upsample. Here also, the spatial attention, this is load that this is a MLP algorithm. Only the high-level features are more, what I can say that, more then it's a more flattened features are used. It is features are more flattened than it's a low-level features in a mixture of it, and the output is calculated. Similarly, for spatial attention select module, they have taken up maximum and average and concatenated and taken for the high-level features of classifications, which is applied for the state sense. Now, this is the methodology how high-level features are extracted. It is shown the max features and average features and taken for the extractions. Now, this is called the self, as I have told, the attention module, SM, self-attention module. they have added the high level features are weighted. Look that more special attention and channel attention are hybridized here in the high level features. Okay, and finally, when it is high level and it is multiplicative and this is the concatenated each other, and the output will be selected from the special attention. So in the special this is the so in the self attention module. So in the high level features, both the channel attention and special attention modules are given more weightage and they have concatenated to get the outputs. Okay. So these outputs are merged and classes are given. So this is the more detailed diagram, or they are reported techniques for the backbone. So they have given of initial block, that stage 1, stage 2, stage 3, stage 4, and there are 2 different models as you have taken, that GSM and SASM it is used, and special attentions module, then example, and look that the input is given and all that patterns are segmented properly. So this is the tree. Look that all trees are segmented as a green. All look here, all the all the buildings are segmented as a deep gray. Paths are segmented as a deep color of pink and black of mixtures, and look the roadsides are given in the pink sides, and all the different classes are segmented properly, and this one sky is represented as a blue. So in this way they have segmented, categorized the different objectives like of this way, clusterized of different objectives of like this way. So here that SSM was applied on high level features to reinforce the propagation of semantic and spatial information for selecting the informative features. So this is the detailed diagram of their structures, what they have used. So in the tailored backbone, in order to capture more spatial information, so initial block is concatenated 7x7 convolutional layers with 32 channels, and 3x3 layers convolutional with 60 channels, and 3x3 convolutional of 32 channels, as you have seen in the previous diagrams of the Taylor diagrams. Now in the stage 4 to 5, they adopted a dilated convolutional. Stage 4 to 5 for dilated. This is the from the stage 4. This is for dilated convolutions. For high levels, features is used. This is for low level features are used. Okay, so these are that high level features and low level features. Look here, all the different techniques what is discussed in this figure, it is described for 3 different scenes: scene 1, scene 2, scene 3. And look that this is of ground truth image, leveled image, and this one is SSM method. This is SSM and CSM, and this is all our mixture methods. SSM, that last one what they have published. And we can find out all the classes are distinguished properly in their proportion as they have reported in their particular literatures. So these literatures applied is not applied for the oceanid detections. but it is highly applicable for the state sense, for the mixtures of the models. Okay, so for the state sense classifications. So let us go for a conclusions of our what we have discussed. So we first discussed how to generate the ground truth. We first discussed the what are the different, why we'll go for the remote sensing. What are the different satellites are there, types of satellites, geostationary satellite, sun synchronous satellite, okay, Landsat satellite, okay, all the different types of satellites and their uses and their heights, how they are using, okay. And also we have discussed about the passive sensors. We have discussed about the active sensors. And most of the active sensors are, passive sensors also useful, but because of absorption capabilities, etc., the passive sensors are not that much of use compared to the active sensors. Active sensors like altimeter data, like of radar data, all are used mostly. So then we discussed about that, what are the how to generate, how the ADs are generated. Okay, so based on the Ekman's transport as well as the Coriolis effect, we have discussed it. Okay, then we come to the point of deep learning techniques. After the AD generation, we want to track, we want to detect first it is AD, and then we want to track it. For detections, for what we can say that for generations of or detections of the ground truth or generations of the ground truth, we can use the method of SLA methods, and to determine from that analysis of that data, we can determine that whether is a these ADs are the cyclonic AD or anticyclonic AD, then also we can track it. Later we have seen the deep learning methods, convolutional neural network methods, and what is the initiation, as a brief initiations of the convolutional neural network, as also the linear 5 architecture, which is generally used, which is very fast used for the basic linear 5 architectures of the deep learning model, and which is popularly used for the deep learning, which is called the transfer learning. Also, we have described in the here, we have shown here, and find that though the transfer learning is popularly applied for the different classification, but for ocean detection, for ocean AD detections, the deep learning may not be useful that much because that's a segmentation, a poor segmentation capabilities. Then we go for a encoder decoder based model. We talk about the 4 different criteria or 4 different methodologies we can segregate. Okay. So for detections, one is the simple methods. I have seen that different models, then different deep learning models, then we gone to encoder decoder module. Okay, then we have started the started that one, the different features to incorporate it, which is okay for the based on that. So also we incorporated the deep attentions models and find out there. So all these models, we have seen that unit architectures also. and find out that unit architecture is not that much of capable, though it is popularly applied in the segmentation module. But later on, we have applied with the deep learning models, and also that encoder and decoder modules. And also we have encoded, we have put there some additional information, weighted information, attention models, and find that the performance will be better if we use the attention information. And also we have seen the track, which is by 12 months, we can, by using a 0 to 12 months, you can track the models. So here for eddy detections and tracking, we have represented using the exception models, modified exceptions backgrounds. Also, it is represented in the self-attention mechanism. Okay, and it is showing that using when I incorporate the self and attention mechanism, the performance may be better, though it is not applied, it is not shown here, but may be better. It is not applied for the eddy detections. For scene classifications, shown. So these are the references as used for the broad reference. A lot of references are used, not shown, and during the presentations we have shown mostly the references used, but a lot of references are used. These are the most of references. Okay. So thank you all. If you have any question, please ask me. I'll be glad to respond it.
Request participants, if you are having any doubts, please unmute yourself and ask questions.
If you have any question for any deep learning techniques or machine learning, artificial intelligence, okay. So as I have told that artificial intelligence is a broad part of the AI. Okay. So AI is all, even if you add it, 2 plus 2 is equal to 4, 5 plus 4 is equal to 9, automatic, all are called artificial intelligence. When there is a, okay, when there is a, some learning is applied, is called, learning means from training data is required to learn the network, is called the machine learning techniques. But when in the deep learning techniques are there, so artificial, look that machine learning is a part of artificial intelligence, and deep learning is also artificial intelligence, is a part of the artificial intelligence, where the learning will be more deeper. That means here we use the multiple features of the input data so that to more better learning. Okay? So these are the basic concepts. If you have any question, please ask me. So the finally I can say it's a more higher level what we discussed with the recent work, and it is a though our group is working a lot, so it is a more higher level what the peoples are working in the directions is the encoder and decoder module. If you know the basics of deep learning, it will be easier to understand. Okay, but even if you are having any question, you can ask, but in the future when you see it, it will be very useful, maybe useful for, I hope that. If you have any question, please ask me.
Dear participants, if you have any questions, you can ask. Okay, thank you so much, sir, for this wonderful session. In spite of your busy schedule, you have accepted our request, sir. Thank you so much, sir. Thank you all the participants. Tomorrow the first session will start sharp at 9 p.m. Sorry, 9 a.m. All the participants join at least 5 minutes before of the starting of the time. Thank you all.
Thank you very much.